So all of us have some very basic ideas of what mathematics is. Right from kindergarten onwards, we are taught how to count. We are taught about the history of numbers 1, 2, 3, and so on and so forth. Mathematics is even more basic than that. Mathematics is the foundation of all science. Mathematics, in fact, is the language of science. Let's see what mathematics is really. It is the art of quantification. It is that one tool which helps you put down your ideas and your logical flows into meaningful forms, into meaningful equations, meaningful numbers, answering the questions of how many, how little, equality, comparisons, and the like. Pure maths, in its own ways, is like a poetry of logical ideas. Let's get on to the business at hand. What exactly does JEE mathematics consist of? JEE maths can be divided into 5 major subheads. You have trigonometry, algebra, coordinate geometry, calculus, and vectors and three-dimensional geometry. Let's kick off with trigonometry then. What is trigonometry? The art of measuring triangles is called trigonometry. Which again begs the question, what exactly it is that you measure in a triangle? A triangle has 2 major components, sides and angles. You have sides, you calculate angles. You have angles, you calculate sides. You have a side and an angle, you calculate other sides and other angles. Your ultimate aim being to calculate all 6 components of a triangle. Trigonometry is the science which deals with relationships between sides and the angles of a triangle, and even more generically, trigonometric functions which describe those relationships. It has applications in both pure mathematics, in applied mathematics, and not just in maths as such, in other fields as well, for example, in your physics, and sometimes even in your chemistry. So what is the scope of trigonometry in the joint entrance examination? Now, trigonometry on its own as such does not have a great direct weightage in JEE, but it is extensively used in questions from other topics. For example, in your questions in physics, and even in your questions in, say, fields such as coordinate geometry and vectors and three-dimensional geometry. Indirectly, trigonometry has other uses. For instance, in coordinate geometry, your parametric equations often get termed in terms of trigonometry. You have functions of trigonometry coming in your calculus, in substitutions, and the like. Your complex numbers consist of trigonometry, your cosine and sine functions to a great extent, and even your vector algebra, if done smartly, would involve the use of some trigonometry. Let's look at the basic elements of trigonometry here. You have ratios and identities, which consists of a left-hand side, a right-hand side, and equating one to the other. You have inverse circular functions, where the focus is majorly on the domain and range considerations. You have solutions of triangle, which is the most basic bit of trigonometry, where you are given a couple of components of a triangle, and you are asked to solve the entire triangle, solving meaning find all the other components of the triangle. And finally, you have trigonometric equations with again domain and range considerations, and wherein you are required to find solutions for a given equation. So let's go on to problem solving strategies for trigonometry. Now, the objective approach is quite useful in solving problems in trigonometry and in solution of triangles. As far as trigonometry and solution of triangles and trigonometric identities are concerned, remembering a formula is sufficient, but of course, let us not focus too much on mugging up loads of formulae. Try solving as many questions as possible so that you'll get fast with the manipulations, so that you'll get a better bend of mind when it comes to trigonometry. Do a lot of solved examples, do a lot of unsolved examples, attempt quite a few questions, attempt assignments, and you'll get lightning faster trigonometry, and it is going to help you not only in maths, but also in physics, and maybe even in chemistry. Then let's go on to the other aspect of trigonometry, which consists of problems on inverse circular functions. Now here's the tricky bit. These problems, unlike many others in JEE Mathematics, are relatively very simple. The only way you can end up making mistakes here is if you do not take care of domain and range considerations. So domain and range are something which should be on the top of your hit list while doing inverse circular functions. Another consideration you have to keep in mind, these problems are generally very simple, and one tends to get slack, one tends to get overconfident while solving inverse circular function problems. Let us make sure and let us be aware of our slackening, and let us make sure that we are very aware during the exam, we are very attentive during the exam, and we don't make such petty mistakes. So common errors while solving problems in trigonometry. Quite often it is required, not just in trigonometry, in other branches as well, but let us talk of trigonometry here. You're required to square your functions, you're required to square a left-hand side, you're required to square both sides, and so on and so forth. Now in such cases, very importantly, extra roots appear in equations. Now these roots did not exist for the original questions. These roots have come in because you've squared this expression, because you've applied an extraneous condition. Take care and ensure that you do not include these roots, that you exclude these roots from your final solution. Again, there can be general algebraic errors during your manipulations. You could be solving something and something else could just come out of your answer. So that is something rather basic. That's not something that is common to trigonometry. You just have to keep your concentration levels up for not just trigonometry, but even for other topics like algebra, for calculus, and so on and so forth, to minimize such errors. There's another very rather comical class of errors wherein you have a left-hand side which is a sign of some certain expression, and you have a right-hand side which exceeds 1, which is of course not possible. Then again, you might have similar errors in inverse circular functions wherein domain and range considerations have not been taken care of. Make sure while solving inverse circular functions that you list down all such constraints and then proceed to solving your question. After you find out your final answer, that does not end your question. Check it out with these constraints whether or not your final answer matches your original question.